What's up guys, Shawnthebro here, and today we're going to be going over some more advanced projectile logic. So today I would like to cover projectile durability and different ways that projectiles can be destroyed. So projectiles, as we have defined already, have the ability to die based on a lifetime. So if the projectile is around too long, it will be destroyed. Also have the ability to be destroyed if they leave the bounds in certain cases. Like if they go out of the range of the stage, they can be destroyed by colliding with other projectiles. So this one I can show off because you'll be able to see it if I do it right. It's a little difficult for me to do both at the same time, but they collide with each other and they're able to be destroyed. I would now like to be able to give projectiles durability because some projectiles can be hit multiple times. Say a larger projectile may be able to take 2 or 3 smaller projectiles until it actually gets destroyed. And a lot of the times the durability will be determined by how quickly the projectile can be released. So if it's like a super projectile, it's probably going to have a relatively high durability, but if it's a tiny projectile that can easily be fired, it'll most likely be a projectile with low durability. Additionally, projectiles can sometimes be destroyed by hitting a melee attack and having the hitbox collide with the projectile before it hits the player. Like that. You can see that the second mutant, the mutant on the right, did not lose any health. They actually canceled the projectile by colliding with, using their melee attack to collide with the projectile, destroying and canceling out the player one's projectile entirely. So we have some options here. We even have the ability, if we'd like, to give projectiles a durability and allow them to basically outlive other projectiles. And I'll do this as an example. So if we replay this, all right. Now I'm going to use the homing thunderball and the fireball, and if I can do it correctly, it's a little tough. Gotta get the timing just right. But I can actually collide with the homing thunderball, destroy it, and then it persists through and still attacks the mutant on the left. This is because the fireball I gave a durability of 2, and the homing thunderball is only taking away 1 durability from a projectile upon collision. So this allows some projectiles to persist through others, cancel out others. They can cancel out each other. There's a ton of different ways you can handle each and every projectile. But this system should help you cover anything that you could plan on doing with projectiles, durability, and being able to cancel them out with certain attacks. So, that's what we'll be covering today, and we're going to get started. But before we do, this is episode 114 of the Fighting Game Tutorial Series. If you'd like to get caught up and see everything that we've done to date, or if you'd like to just follow along with the series as it progresses, you can click this icon in the top right corner right here. What that does is that is the playlist for the Fighting Game series, so you can see everything that we've already done, as well as every episode after this one will be added to it as it comes out. You can also click this episode right here, top right corner. That icon will lead you to the projectile colliding with other projectile collision. So them being able to cancel out, them colliding with each other in the first place, and what that does, any sort of logic like that. Otherwise, let's get started. So there's a few things we're going to do today. Most of it's going to be in the blueprint with the hitboxes and the projectiles themselves, but we're also going to do some in code. We're actually going to make the projectiles spawn and stem from a code class. We actually had this default projectile BP, which is fine, and we're going to keep it, but this was just a child of an actor before. I've now made a code class just to follow the rest of the series with how we've been handling the code. Is the base class and the blueprints are for the children and the specific classes and anything that requires the blueprint like the mesh and things like that. So we're going to follow that same logic. It's going to be very simple what we're going to do, but it is worth taking a look at. So if we do add new C++ class, and we're going to actually go off of pawn this time as opposed to actor. This is because pawn can receive input from a controller, so it gets a few additional benefits in here. Now, the actor is perfectly fine for everything that we've done. However, the pawn is essentially an actor that is allowed to be possessed and receive input as it says here. So we could actually control some of our projectiles if we'd like. We can also do different things with their time dilation to pause their particle effects and make some of our lives easier than with an actor. Very similar classes, but it'll give us a few additional benefits that we want to have with our standard actor. So I'd recommend using pawn as the default class. Once you click next, you'll have to put in your name and the path. I usually leave the path alone because this is where all my source files are, all my code files. But I would rename this, and I called it base projectile. Once you hit create class, as long as it succeeds, if you have Visual Studio open, it may open automatically, but if not, it'll be in your source folder here. So you can see I have baseprojectile.cpp and baseprojectile.h. So open both of those guys up. When you get in there, you will see these three functions, all your includes generated body. So actually, you'll see everything here. Actually, you'll see everything here. Let me reiterate that again. And then this is all stuff I've added. You'll notice some stuff is commented out. I'll explain that in a second. Let's look at the baseprojectile.cpp. In this one, you'll have all the functions. The only thing that I've added in the CPP is this stuff. So let's talk about this for a second. That's the wrong file. Let's go back to baseprojectile.h. So in the baseprojectile.h, this is where we're going to set up our variables, basically our attributes or our parameters and identifiers for our base projectile. Now, the base projectile is never really intended to be spawned. This is the overarching code class that essentially everyone can, any projectiles can access this and grab the default values, and then we can set them in the blueprints like we've already been doing. Like for example, we have these functional BPs, and I have like, this is my fireball. So I set up my default values in here and I change anything I want in here. Okay. And so with that, what we can do now is go through and add, we're going to add the new variables first. And then if you'd like, you can actually add the old variables that are in the default projectile BP to the code class. That way you don't have to, that way you can access them directly from the code class and don't have to go into the blueprint. And what I mean by that is this default projectile BP here. It has these variables here. Lifetime should be destroyed upon collision, should display hit effect, and velocity and hit effect as well. I've taken these top three at the least and put them in the code class, but I've commented them out for now as to not add any confusion. But toward the end of the episode, I'll show you how we can actually just replace the blueprint variables with these code variables. That way they're all in the same spot and we can access them from other files if we need. For now, the only real thing that we need to worry about are these new variables. So we're going to add the can be destroyed by durability, can be destroyed by melee, and an integer for durability. So can be destroyed by durability is essentially my way of saying if this projectile collides with another projectile, can it be destroyed? Can it also be destroyed if it collides with melee? Because, you know, being able to melee it, being able to hit it with other projectiles, it's all going to decrease the durability of the projectile until it eventually gets canceled. So, if we cannot be destroyed by durability, we probably shouldn't be able to be destroyed by melee. You can separate these. If the projectile is not able to be destroyed at all, then there's really no reason for it to be destroyed by melee. But the counterpoint, if it can be destroyed by melee, it most likely can be destroyed by durability. You could separate these if you want, even more so. Like can be destroyed and then can be destroyed by durability and can be destroyed by melee. So can it be destroyed period and then one or the other. However, for my case, I only need these two. So essentially you could have a projectile that could be destroyed by colliding with other projectiles but could not be canceled by a melee attack. Then I've also added durability, which as it says, it's the amount of hits it can take before being destroyed. That's mainly true. For right now it's true. You could have another attack that, you know, takes more than one durability away, but for the case of this game and this template, my thought is to essentially have the durability be the number of hits the projectile can take before it is canceled or destroyed. So add these three variables. And then in the CPP file for the base projectile, I've set up the default values for the ones that, the new variables. So I've set can be destroyed by durability and by melee to false by default. If you have more of one or the other, like more that can be destroyed or more that can't, feel free to set it to be true or false, regardless of what, or based on what you need. But for me, false is the default. And the durability is just 1. So essentially, if it can be destroyed, it probably only takes 1 hit to destroy it. Once you build again, you'll now have access to this class in your Unreal. So you want to go into your default projectile BP and you want to change the class settings, parent class, instead of being actor, make it base projectile. When you do this, you'll actually require no changes. You don't have to change anything in here to make it work. A pawn is just an actor after all. Okay. So at that point, you're done with the default projectile. Again, we can come back and replace these variables with the code variables. But you don't have to do anything with that now. We'll do that at the end. I just want to show you how the logic works. That way you understand it, and then we can add in the additional cleanup afterward. Okay, so now we need one of our projectiles that we're going to be testing with, and that for me is my fireball, or my projectile horizontal is what I've called it, just because I was calling it a default name. And we ended up making the fireball projectile. So the projectile horizontal, or our fireball, here has the same logic that it has had the whole time. Nothing changed there. But really what we want is the class defaults. We want to set up some other additional things. So first of all, if I want to give this a durability of a value greater than 1, meaning that it can take more hits than 1 before it's destroyed, I'm going to uncheck should be destroyed upon collision. It's not required that you do this because you could destroy it when it collides with the, with a projectile regardless of the case. Like it might have more durability, but one projectile can come along and destroy it because it takes away, say, 8 durability or something. Basically, trying to think ahead here. What I'm saying is each case can be different, so you don't have to model it exactly how I have it here. What I want here, what I'm trying to show off here, is that I don't intend for the fireball to be destroyed upon collision with other actors first. It can be destroyed immediately upon colliding with a user, if we would like. But I don't want it to be destroyed upon collision when we just collide with another projectile or necessarily melee, depending on how we set it up. Then I have given the ability for this fireball to be destroyed by durability and destroyed by melee. So yes, it can be destroyed and be destroyed by colliding with other projectiles, but it also can be destroyed by a well-timed melee attack. I've given it a durability of 2, which allows it to take 2 hits. Essentially, it can take the hit with another projectile and continue on, or if we made it 1, it could be canceled out by another projectile. So that's up to you. Again, set your projectiles up as needed. This is entirely up to the developer or the designer and whoever's making these decisions. Each projectile is probably going to be different in one way or another. So just showing you what I have so you know what you're seeing on the screen and how it correlates back to what we've set up. Now the other thing we want to do is go into the Hitbox Actor BP. Okay, now in here we have this onComponent begin overlap, which we've used as essentially like this hub for collision. So we do so much stuff in here. All of this is essentially stuff that we've done in previous episodes, minus like 2 nodes we're going to add here. And then we're going to add these nodes here up above today. I point that out specifically because there is a ton of logic in here. You might want to break this into a function, but I just want to show you what we'd be doing today. So if you're looking at this and you have your logic in here as well, you kind of know what to expect and what we're going to be changing today. So in our onComponent begin overlap, what we do is we check and see if this hitbox is a projectile. If it is, and we're colliding with another projectile, we do the logic to see what happens when projectiles collide with other projectiles. If not, we're going into our static mesh component, or well, casting to see if it's a static mesh component. If it is, we check and see if it is our hurtbox. This cast failed that goes into this logic down here is for complex hurtboxes, and it's essentially a capsule collider specific hurt boxes more along the lines of Smash. We did an episode on that, but that's not important for today. Right now we're using what I call the simple hurt box collision, which is where we have the square that we've lined up with the balance of our character, and what we want to do is determine basically if the projectile collided with the hurt box. There is something we need to add now, though, because now we're introducing other types of collision. Like, I want to be able to collide with a hitbox that a character spawns from a melee attack to be able to decrease from the projectile's durability and or destroy it directly from the melee attack. And so because of that, we could have static mesh components that don't have component tags. Okay? So we need to add some additional logic in here. Before, we were grabbing the component tags of the static mesh component that we were colliding with, which in our case would have been the mutant BPs. So if I come in here to my HB collision box, or really one of my hurt boxes, so high, mid, or low, hurt box, high, mid, or low, and I scroll down in the class defaults section here, we have component tags, and I have hurt box high, and then I have mid and low. These are used for collision checks and, verifying that a collision with a component of the mesh that we want to be able to deal damage with has been collided with. And that's been working fine. We don't need to change that. But now we want to be able to access specific indices from this component tags array if they exist. If they don't exist, we can also make some assumptions. So I spawn hitboxes. Hitboxes are spawned when moves are performed that would then lead to creating a hitbox. We don't add component tags to those at the current time, so 0 will not always be a valid index. So where you have this logic where we check and see if it contains this hurtbox substring to know if we're colliding with a hurtbox or not, I'd recommend adding this in here. Basically drag off your component tags, type is valid index, leave it at 0, because if we don't have anything at 0, we don't want to get an error. This has a return node. You can drag off of that and type branch. If it's true that it's a valid index, then we do the same logic where we check to see if the index at 0 contains this substring, and then we, go further on. Basically, we're saying, okay, we've collided with a player and their hurt box, so we want to deal damage. Again, nothing has changed in any of that, so don't worry. However, in the other case, if this is false, this has collided with a static mesh component that does not have a component tag. Most likely, this is with a hitbox, not the hurt box, but a hitbox that a character has spawned. Remember, we do the projectile check first, so we know we haven't collided with a projectile, and we know we haven't collided with a hurt box now. So this is the hitbox logic for collision. This can vary a little bit based on the behavior you want, so I'll try and explain what mine does and what you could do to change it. But essentially, here's what we're going to do. We need to make sure before we do anything, we don't want to just assume that this is a hitbox actor that we're colliding with. To do that, there's a very simple method. OnComponent begin overlap has an other actor, which we're using for our projectile logic. Well, we can also use that other actor, it's this line right here, and drag it directly into a cast the hitbox actor BP. Okay. If this cast succeeds, we know that this projectile is colliding with another hitbox, and then we can go on to do the logic from there. Once you have this cast the hitbox actor BP, let's talk about the two spots we could use to get into this check. So first things first, if the component tags is valid index branch fails, it's false, then we want to check and see if we're colliding with a hitbox actor. That one we discussed. There's another case as well. We could collide with a component tag that does have an index of 0, a valid index of 0, but it might not have this substring in it. We might want to have substrings on our hitboxes in the future, but we don't want to limit ourselves to, we can't have that because our hitbox actor logic will fail. So instead, if this contains is false, we also want to bring it into hitbox actor BP. So both of these sections go into this top root. Okay, now we have to think about our logic that we want for this part. So if a strike hitbox, the red hitbox that deals damage, if that hitbox collides with this projectile's hitbox, that's when we know we can cancel it out or check to see if it has durability that we can decrease. We don't want to do it with other hitbox types because if you have a proximity box, you wouldn't want to do it. A throw box, you probably wouldn't want to do it. I mean, you could. And other things like that. So, off of our casted hitbox actor, we want to grab our hitbox data, which is our structure. And we want to drag off this guy, and we want to break and get all of the data. Okay, you'll have all of these things in it. We only care about the type. So I'm going to hide unconnected pins. I'm going to have hitbox type selected. And that's what I have right here. So then I'm just going to check if the type of this hitbox is a strike hitbox. So equal enum and then change it to strike. I bring that into a branch. If it's not a strike hitbox, I don't do anything right now. There's nothing I want to do with this projectile or its hitbox at this point. I'm not hitting it with a hitbox that could cancel it, so I don't do anything. If it's true, however, we want to make sure that it is not the owner's hitbox. They can't cancel their own projectile. So say I shoot my homing thunderball and I go and I attack it. I don't want to be able to destroy my own. Most likely. Again, you could change this depending on the projectile. But for me, I don't want to be able to destroy it. So I have to check and make sure that the owner of this hitbox, remember, I know it gets a little bit confusing. We're in the hitbox actor BP, but we only go into this logic if we are a projectile type. The other hitbox logic is handled in other functions that we've set up and altered many times. So this hitbox here that is taking in the other actor, okay, the one we're casting to right here, this is the hitbox spawned by the character that is not using the projectile. So in this case, this is the character that's trying to cancel a melee attack with a hitbox. Or they might not be trying, maybe they just attacked and it collided with the projectile. But regardless, this is the hitbox that is colliding with the projectile's hitbox, okay? It's very important to note that. So we're using that, okay? We're getting owner on this guy right here. Get owner. Because the owner of this hitbox is going to be the player that spawned the projectile. We set that up. Okay, so we don't want that to be equal, not equal, or exclamation mark equal, or you can type out not equal. We don't want it to be equal to get owner. You can see nothing is plugged into the target. The self is the target. We're making sure that the owner of the hitbox that's being spawned over here is not equal to the owner of this hitbox, which comes from the projectile. Basically, the owner of each hitbox that's colliding with each other, so each one of those, they don't have the same owner. That way we can't destroy our own projectile. If that's true that it's not, then we want to go to the next stage. If it's false, we do nothing. For the next stage, what I'm doing here is I am grabbing the default projectile BP so that we can grab data from it. At this point, we know that we have a hitbox and it's colliding with a strike type hitbox. So there's a projectile and a strike type collision going on here. At this point, we know that we want to figure out if it can be destroyed or if we should remove some of its durability. So I have get attached parent actor, which I plugged in self just to prove my point, but it's not required you do that. You can just do get attach parent actor. This was just confusing me looking at this with all the data in here. I was trying to keep myself straight. So self is the projectile's attached parent actor. And the reason we use the attached parent actor is because the hitbox is actually attached to the projectile. So right now we're in the hitbox actor BP, and that's where the collision is occurring. But we do need to know about the details the projectile itself has. The hitbox could know this data, depending on how you set it up in your game. But for now, it's the projectile itself that knows the data. So what I do is I get essentially my projectile and I cast it to the projectile type. I cast to default projectile BP. You could cast to your new code class just base projectile, but we haven't moved our variables over yet. And also you may need the mesh or the hit effect or some things that you might want to leave in the blueprint. So I use the default projectile BP, but either should work here as long as you set it up correctly. And then we're going to go into the logic that we want to define for each of these things. Different games do it different ways, so I wasn't sure which route to go here. So feel free to change this to your liking. The first thing I check is to see if this can be destroyed by melee or not. If it's false, we don't do anything. This whole section here is for projectile hitboxes being hit with melee hitboxes. So if we say we can't be destroyed by melee right off the bat, then we don't do anything. If we can be, we'll continue to look further and we'll go into this branch, true, we'll go into this function, update projectile durability. You won't have that yet, we're going to create that. So add a function here, plus function, and call it, you call it whatever you want. I call it update projectile durability. Okay? Now in here, what I actually do is I see if this projectile can be destroyed at all, really. Okay? And if it can be, we're going to decrease from the durability and check to see if it should be destroyed now. Like if it's now at the point where it can be destroyed. If it can't, we're going to say, nope, we still have durability remaining. All right. So the way we do that is our update projectile durability function is going to have an input parameter and an output parameter. So for the input parameter, I have the projectile reference that we want to check. We want to be able to use this from multiple places, including our perform projectile collision logic function. We haven't gotten to that yet. We made it in the other episode for projectile collision, but we haven't covered the changes we're making in today's episode. But what you'll want to do is make sure that you do have this projectile reference so that we can call it from multiple places. And it's my default projectile BP, object reference. Right here. Then we have an output parameter. You can add these by clicking the pluses, by the way. And I've called it has run out of durability, and it's a Boolean. Okay, so if we cannot be destroyed by durability, then I'm just saying false. We haven't run out of durability. I mean, technically it's true. If we can't be destroyed by that, then yeah, we still have durability. But also, it's there because if we have run out of durability, then we know, hey, we can destroy this guy now. So, okay, if we say true, we take the projectile reference and get its durability. That was a variable we added in the code, remember? Right here. And so we literally get durability. And then I'm doing integer minus integer. And I'm leaving it as a default value of 1. Essentially, I'm taking 1 away from the durability, meaning it's been hit 1 time. And then I'm going to set the durability of the projectile reference back to that. So this is the new durability. You could also just decrement it if you want, but I do want to keep it open in case you want certain projectiles to take multiple durability loss. So you could have this whole basically web or chain of, okay, these hitboxes on these projectiles cancel out these ones, or these ones are equal if you want to get more advanced with it. So you could be a little bit more elaborate. Regardless of how you do it, I now check to see if the result here, you can drag off of the end of a set node to get the result of it. And I'm checking to see if this is less than or equal to 0. If the durability is 0, I'm putting that as my bottom line, saying if it's 0, it will be destroyed upon the next collision. So if this is false, meaning it's greater than 0, then it also goes into it goes into the return node where has run out of durability is false. This is because it hasn't run out of durability, plain and simple, so it can keep on going. If it's true, I actually set the should be destroyed upon collision Boolean that we've set up many episodes ago for our projectiles. This is kind of an extra step because we could just destroy it here and now. The reason I actually set this up is because if I set this, I could actually go into our projectile logic at any point, check this value, oh, it should be destroyed, and then choose to destroy it or choose to keep it alive until it has another collision. Again, very specific use cases here, but there's so many different types of projectiles, so I'm trying to keep it as open as possible for you guys. Then I return this value. It doesn't really matter. You can either connect it or manually check it. Either way, these are going to have the same value because this is only ever going to be true here when we're returning this. But whatever one's easier for you to look at and understand. So you can see update projectile durability had a little bit extra logic that we didn't need when hitting it with a melee attack. But that's because we're also going to use it in our projectile-to-projectile collision. Okay, and make sure you pass in your projectile reference here, the casted actor Make sure you pass that in for the projectile reference so it knows. Then our output parameter here, I drag directly into a branch. If it's false, it hasn't run out of durability. Again, we don't want to necessarily do anything with it. You could choose to display a hit effect because there was a collision, even if it's not being destroyed. That is up to you. If you want to do that, by all means. I didn't do it here, but no reason in particular. You probably should have a hit effect that's different from the actual destruction effect. That way there is still some feedback from the game. I don't currently have that, but we could easily add it. For now, I'm just leaving it alone. And if it has run out of durability, then we're going to do our regular display hit effect logic and then destruction logic. We actually do it right here, so you could copy your logic if you'd like from below and paste it up here. I'll go over it again real quick because it's simple, but basically the projectile reference, that's what this is, has a should display hit effect boolean right here. And then what that means is when a collision occurs, should an effect be displayed? Really, when this is going to be destroyed, probably, should it be displayed? So like the fireball, it kind of blows up. It becomes an explosion when it collides. The rising tornado does not have an effect when it collides because the animation and the effect itself actually take care of what the projectile does, if we're calling it a projectile. It's really just a special move. But essentially, my point is, you could have projectiles that don't display hit effects, and that's what this was for. So if we do want to display the effect, we want to also spawn the emitter. Our projectiles have a hit effect, which mine is the explosion for the fireball, and we have an actor location we can grab from the default projectile. We just want to call spawn emitter at location, passing in the hit effect and the location, and there you go. I did actually realize a minor issue that I have here. So I should also do this and make sure that even if there's no hit effect to be displayed, we still want to destroy that projectile. Okay. So you can see if there is no hit effect to display, we just want to skip the spawning in the emitter. But regardless, either way, we're calling destroy actor on this default projectile BP. You can follow it along. So we're destroying the projectile, and then we have to make sure we also destroy the actor. So to do that, how we usually do it is we would check this boolean, should be destroyed upon collision. However, we know if we're at this point, we're going to be destroying it. We have no reason to check if it should be destroyed or not. And so I simply check and see, is the actor already being destroyed? I leave it as self because now we're trying to destroy the hitbox, not the projectile. That's already gone. And then I go into the branch. And if it's false, that's not already being destroyed, destroy it. Could be useful to check if the projectile is already being destroyed as well. Could be cases where you'll need that. Feel free to check it, especially if you get errors saying, you know, this actor is already trying to be cleaned up or destroyed. But there you go. That's the collision logic for melee to projectiles. You could also change this right here, where where we check to see if we can be destroyed by melee. If you want any projectiles with this boolean set to true to automatically be destroyed, regardless if it has durability. Say you have like a projectile with 5 durability, and you don't want to have to like keep hitting it until it gets down to 1 durability to be able to melee it. You could also just destroy it here as opposed to calling this function. But we still need this function, so don't get rid of that. But just an idea for you. Depends on how you want to set it up. Now, there is a lot in that event. This next part is actually much, much simpler. It's actually just 2 nodes, I believe. So we want to go into our perform projectile collision logic now. And we want to basically just add an additional field, an additional check here to decrease our durability when 2 projectiles collide with each other. Everything else in this function is the same as it was the previous episode. But now what we're checking is, should be destroyed upon collision. If it's true, we were going through and destroying it. That's perfectly fine for projectiles that are going to be destroyed on any collision, regardless. We don't have to worry about durability, period. However, if that's not true, what I actually want to do is update the durability of the projectile to determine and see, really, if it should be destroyed when it has a collision. Now, this is our same function that we just used. So make sure you grab the right projectile type. Okay, so I grab my projectile reference from my input parameter. It goes in here. It's going to do the same logic. It's going to say, can we be destroyed? okay, if we can, we're going to decrease from the durability. And if so, we're going to set should be destroyed upon next collision to be true. Actually, with this, I just realized you'll probably want to put this to 1. That way, as soon as it hits 1, it'll be destroyed upon the next collision. It wasn't bothering me because I only used 1 and 2, so it was always hitting the numbers that I needed. But if you want to get into more projectile combat and say you have, again, durabilities like 10, whatever, you want to make sure this is being destroyed when it hits the value that you give it. So it should be less than or equal to 1, probably. Up to you how you want to set that up. And that won't screw up the melee code either, because this only gets called when we're having a collision with the melee and the projectile. So if it's 1 by default, even though we're subtracting 1, it's still going to be less than or equal to 1. So it will then say, yep, we should destroy it. Otherwise, it'll keep it alive. The only way that you'd have to change anything with this minor update is if you wanted to have to hit the projectile multiple times and then melee it to destroy it. You'll want to make sure that it does go to 0 before it actually gets destroyed, as opposed to just opting to destroy it like I did in this function. So you might want to check your Boolean there that I was actually just talking about, this guy, before doing it. So my apologies there for any confusion, but basically I'm going to leave it alone because I don't have projectiles that are that advanced. Honestly, I've never seen a fighting game that does. I don't know if they exist, but keeping it open, anything you want to do, you know, you could be the first. You don't have to model it off something. So just keep that in mind. But yeah, we just do it on the false of should be destroyed upon collision. All right. And then everything else is the same here until we get into the other projectile, because we check both projectiles in this function, and we want to do the same thing. Where the false is on the should be destroyed upon collision, there was nothing here before. Now we're putting in update projectile durability. And we're passing in the projectile reference right here, the one that was casted in the middle of this function. Okay? So basically you're going to check it for both projectiles when there's a collision, and destroy the appropriate one if needed. Also, if you'd like, you could always feel free to check destruction immediately after if you want, if you don't want to wait for the next collision. It's not required here because, again, you know, I'm checking to see if there's any durability left, and then I'm setting it. Yeah, it can be destroyed next time. But if that's easier for you, if it makes more sense, feel free to just run a check afterward. Say, you know, am I ready to be destroyed? And then destroy it. Now what we're going to do is edit the code variables to be the actual variables that we use for our projectiles. So you can uncomment everything in the base projectile.h and base projectile.cpp. Once all these are uncommented, we will then build the project, run the game, and of course we will be able to use these variables in the editor, in the engine. The main thing is that I've named these variables the exact same as the variables in the blueprint. So when you do this, you'll have to replace the blueprint references with the code references, but it's very easy. I'm going to show you how to do it. So now that we have the editor open, we are going to go into our base projectile BP, as well as all of our individual projectiles. So for base projectile BP, we're going to remove the variables that we don't need anymore. If they have references like this, then you can make sure you find all your references first as opposed to just deleting them. That way you know you won't miss any. Then once you get rid of them, you are able to, of course, delete these blueprint variables, as we only need the lifetime that is available in the code. So I can delete that one, and then I can grab my lifetime in this class, because remember, this is a child of the code class, so it will have access to that lifetime variable. Okay. We're going to go into all of our individual child projectile classes. Do the same thing if you have any references, but otherwise just make sure you set up your class defaults again. All your projectiles could be different with their lifetimes, their booleans that we set, so make sure you set them again, as they will be reset when you remove the booleans from the blueprint classes. So I'm just going to do this for all of my children. Make sure I set up everything exactly as it was. I forget exactly how much I had for the lifetimes, but I can easily change that when we get into more game design related episodes and logic. Okay. And now with all this done, what I do is I run the game and I find out, oh yeah, of course there's other references here, and they're all in the Hitbox Actor BP. So I'm going to go into the Hitbox Actor BP. I'm going to manually click on this error, but it doesn't matter where you go in from. Just go to your Hitbox Actor BP, try and compile. You'll get a bunch of errors, and you can go to them. It's because these don't exist anymore, because it was accessing the old blueprint variable. Check the name of the variable, and then replace it with the new one, that is the code one. Very simple. All you have to do is literally delete the node that's there, and then get that one again. It's the same thing you're getting. You're putting the same thing there, but technically you're putting the code variable in instead of the blueprint one that was there. I'm going to show you me doing it for all my variables. There's not that many. It's mainly these booleans should display hit effect and should be destroyed upon collision. But I want to make sure that I replace all of them properly. That way all data is correct and all of our logic matches what we had before. Then, once you're done replacing all these, you're good to go, and your game should work as usual. If you have any other errors, your logic might differ from mine in some ways, or perhaps I may have missed one of the references that I had set up in another spot. So simply just replace it with the code variable now, and you'll be good to go. Everything should work as intended. But other than that, guys, that's pretty much all I got. This covers projectile durability, being able to destroy projectiles with melee, and all sorts of other additional projectile logic that could really come in handy. So, just a quick recap. If I fire 2 projectiles at each other at the same time, destroyed, right? If I fire 2 different types, I didn't charge it up for long enough. If I fire 2 different types of projectiles, and one has a higher durability, they can actually pass through each other, if we'd like to do that. Meaning that, you know, one will basically be canceled out and the other one will continue. It can hit the opponent. And I can also do this, where I can cancel out certain projectiles based on that boolean as well. With a melee attack. So we have all sorts of options here. It's going to make our game a much more enjoyable experience, in my opinion, to be able to fully configure these things. I really love all the different mechanics that you can have, and being able to see them and test them out is always super fun too. So I hope you guys enjoyed. If you did and it helped you with your projectiles, please subscribe. It does more for myself and the channel than anything else you can do. I just really appreciate it. I want to give a huge shout out to my YouTube membership and Patreon supporters and subscribers. Thank you guys so much for everything you do and for continuing to help me help support me in making these series. I really, really am grateful for that. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. Be happy to get you situated with any problems that you're having, and it's completely free. But anyway, guys, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one, guys. Goodbye.